This is llama.cpp serving 4 users of the same AI agent. They all share the same system prompt and tool schemas. That's what an agent looks like. Watch the time to first token. Every tenant sends an identical 550 token preamble. 1 user is fine, 386 milliseconds. 4 users, 4,200. And note the requests are strictly sequential, nothing overlaps, so this is not queuing. 8 tenants is the same as 4, because the failure saturates. Here's why. The server picks a conversation slot by longest-common-prefix similarity, and it accepts any slot above the threshold. The default is 0.1, but because every tenant shares that preamble, any 2 different users are already about 0.7 similar. So every slot looks like a valid match for every user. This isn't inferred, the server says it. It picked a slot at 0.716 similarity, someone else's conversation, and reprocessed 220 tokens it already had cached. With the threshold raised, 0.955 and 36 tokens. Only the new turn. The fix is 1 flag. Slot-prompt-similarity from 0.1 to 0.9. 10.5 times faster, 220 tokens down to 36, and 0 lines of code changed. And 0.9 isn't a guess. Sweeping 7 threshold shows a cliff, not a gradient. It falls between 0.7 and 0.8, and the measured inter-tenant similarity is 0.716. Clear that number and everything works. Miss it and nothing does. But here's the part one didn't expect. I built 6 different prompt shapes and swept every one. Below about 0.5 inter-tenant similarity, the threshold changes which slot gets picked and changes no work at all. Recomputation is identical at every setting. Above it, the wrong value costs 6 to 17 times. So there's a boundary, and it's measurable from the server's own log before you tune anything. And the cliff isn't at a magic constant. For each sensitive shape it lands on that shape's own measured similarity. 0.543 drops between 0.5 and 0.7. 0.716 drops between 0.7 and 0.8. That was predicted before the run, and it held on a shape that didn't exist when the prediction was written. So you don't guess, you measure your own similarity first, and that tells you both whether to tune and what to tune to. I measured this on Microsoft Cobalt 100, Arm Neoverse N2, on Azure. There the regression is 10.9 times. But look at the bottom 2 rows, similarity and tokens recomputed are identical on Arm and x86. The scheduler makes exactly the same decision on both. Only the price differs, and the price is prefill time. One last thing. Every comparison goes through an adjudicator with thresholds committed before I collected any data. One of my own results came back rejected. The fix does not quite reach single tenant parity, there's a real 4% gap. It stays in the table. A benchmark that only reports its wins isn't one you should believe. Every number reruns on a free ARM runner. Fork the repo, click Run Workflow, 47 minutes later you have the whole thing. 60 runs, 0 dependencies, 0 cost, and every raw server log committed so